I'd like to talk a little bit about chimney liner sizing and go through this handout that I have for you. My chimney liner sizing handout is from Hart and Cooley, and it's just one specific manufacturer that makes a liner as a repair or as a kit to maybe manipulate the size of a system that might be oversized even. So I want to talk a little bit about this. So a couple of other things that I'll point out here is obviously a liner system, the aluminum chimney liner systems, you could use them for certainly a new system or an existing interior of a masonry or a factory built chimney or a system that either A is in need of repair. Maybe they've got issues where there's an excessive amount of condensate, or there's a problem with the chimney where it's breaking up, whatever it might be. There can be a number of things that might be going on. The liner is much lower mass, and it might be a really very good system on there. There are other systems that might be better. For example, a hard B-line pipe might be much better. The fact that it's much smoother on the walls, whereas most of these chimney liners are very corrugated, so they have a lot higher resistance than what is normal on there. So you want to be a little careful on some of those things. They talk about maintaining an air gap between the liner and a chimney if it's at all possible. Now this is really hard to do. If you're installing one of these liners, they're super flexible, and to prevent a liner from touching the walls of a chimney vent system, it'd be almost impossible. I don't know that you could necessarily guarantee that could happen. The other things that I wanted to hit up on, the aluminum liner system, as a note on here, I want to point this out. This aluminum liner system right here, it says do not use this liner to vent a liquid or a solid fuel appliance. So or a listed category 2, 3, or 4 appliance, or a category 1 appliance that might have efficiencies greater than 83%. Now I want to specifically hit this up as to why they're saying that. What they don't, number one, with liquid or solid fuels, their temperatures of the vent system are higher than it would be for a B-vented appliance that would be 80%. So that's the reason there. The other thing is a category 2, 3, or 4 appliance, they don't want to have you vent those because there's no manufacturers that I'm aware of that want you to use those types of systems. So you have to be careful with that. Why do they have the category 1 appliances that have efficiencies greater than 80%, 83%, that they don't want you to use them? They are worried the probability of having condensate in those systems is so much greater on an 83, 84, 85% efficient appliance. So that's the one thing you have to be careful with and prepared for. So that's probably part of the reason why they are saying that. Now, if you go on YouTube, you can find out all kinds of videos and things that show people installing them in certain applications, and some of them don't do a very good job of following rules such as these. And I get why they're doing that, but there are some better alternatives out there. One of them that, as far as for, what do you do in those cases where you can't install them in these appliances? They make such a thing as not an aluminum liner, but a stainless steel liner. And so that's also very corrugated, and that might be a better option for some of those things. All right. So let's take a look at, we're going to take a look at some of the other sizing. They talk about the sizing of this, and they say that it's determined based on the requirements of the NFPA 54, which is our fuel gas code book. And it shouldn't be sized less than what the appliance manufacturer specifies. So, in other words, one of the things that they identify in here is that the appliance collar cannot be larger than any part of the vent system. So if you're not sure what that size is, you can obviously get a hold of a manufacturer of whatever liner you're using to determine that. Liners are kind of a different beast. You probably almost want to use their system for sizing as opposed to the code book. Now the code book, they automatically, just like these systems, because of the resistance of these lining systems that are corrugated and that are not smooth, they specifically want you to reduce the table values by 20%. And there's a lot of similarities on that, and that's primarily off the main normal system. As far as the installation of it, I'll chat a little bit about that. So, what goes on with this? So, obviously, with any vent system, whether you put a liner in or not, that may or may not help you as far as getting a system to vent properly. So, and if you have a system that's deteriorated quite a bit, I think you got to be a little careful putting a liner in it, because the liner isn't going to be real super strong. It's certainly not going to hold up to bricks falling and things like that that might be going on. The typical terminations, they all would apply in there, those types of things. Those are very typical types of things that are going on here. So now, as far as what things would be used on here, so I want to hit up a little bit on. So in this case here, every system, whether you have a liner or not, they need to have some sort of a cap, and some sort of a chimney cap or some sort of a vent cap. There might be some sort of a termination fitting that might adapt from the cap directly to the or to a flexible liner. So, and that would be provided by the manufacturer of that system. So you'll need something like that. And obviously, the idea of this is that we want the liner to be able to slide over the top of that. And then, of course, there will be a flashing. And the flashing is really more to say, I don't want the rain to run down inside my vent system or inside the chimney where I'm putting this liner in. So that's the job of that flashing. Of course, then you have the liner. And if you're in a chimney that would have a brick or masonry type chimney, you're going to have some sort of what they call a mortar sleeve. And that's really just a sleeve that's just allowing you to move the corrugated liner through it, and that gives you the ability to have a little bit of movement in there. So that's primarily what there is. And then, of course, you can have a single wall collar, and that really could almost be just regular old single wall pipe that would normally be, so your typical 24, 26 gauge type on there. So those are kind of typical. There is such a thing as a kit that is a pulling, what they're showing, a pulling cone. That's shown here in figure E. That particular pulling cone is one that would attach directly to the liner, and usually people will drop that down with a rope or a chain or something that would allow you to kind of pull that down in there. Now, what these corrugated liners, they're going to come with in a roll that might be 35 feet or 50 feet long, and you're going to have to stretch them out. Stretch them out to give you that 35 feet or that 25 feet or that 50-foot length. You're going to need to do that. So you'll be pulling that down onto there. So, and as I said, they're talking about preparing for the liner or preparing the liner. They're saying stretch the liner out with a slow, steady pull to allow it to unwind as it stretches. So I think they're insinuating here that you potentially would allow the liner to stretch out as somebody is pulling it. I think that's one possibility. The other way, you could extend that out ahead of time and extend that out to the length that you feel you're going to need, and then make your adjustments as necessary. So what's happening is they've installed this thing over the top here, and then they're pulling this thing down through the existing chaseway or the existing chimney. And this is already open, and you have to pull it through there. So it's a two-person job at a minimum on this thing to really get this to work the way you want it to. So, and they're talking about, obviously, make sure you have a little bit of extra length, and make sure that you are pulling that liner through the holes and things like that. So you got to be a little bit careful as you are installing them. So it's definitely a job where it's a multi-person job on this thing. So, all right. So once that is through that chimney, then obviously you can do the finishing. And I wouldn't probably do a ton of the finishing work, what they're showing here. until after I have it through the penetration here, that the sleeve is installed, just as they're showing here. And this is where that sleeve would be installed. That would be typical of what it would be. And then obviously you can seal that up with some sort of like a mortar or a silicone of some sort that would be sufficient temperature ratings. This one's identifying the B-vent adapter. And so whatever that B-vent adapter is, you're going to probably need some sort of a kit. And most of the time what people do is they might put a couple of screws in here. Most likely they would be a stainless steel type screw. You got to be really careful with not using screws that are going to deteriorate due to the acidic nature of the condensate, which will likely happen on there. So you want to be a little bit cautious on that. All right. So let's talk a little bit about some of the sizing. So specifically on the sizing, the normal things that when we would size a normal B-vent chimney, or a, whether it's single wall connector or a B-vent connector, really wouldn't matter, but it's the typical types of things on here. And what we are going to be concerned with is we're going to be concerned with the chimney height, we're going to be concerned with the lateral connector, and we're going to be concerned with the lateral length. And this is a manufacturer's table. So in this, again, it's specifically category 1 appliances. So in this particular example, I've outlined a couple of units already. So for a system, let's say if I happen to have a system with a 15-foot high vent system, and I've got, let's say I'm going to use a single wall connector, that if I've got an appliance that is, let's say 60,000 BTU furnace, it would be pretty typical with a 5-foot lateral length, connector length, that would tell me that I would likely need a 4-inch if it were a natural draft type of appliance. That would be the natural maximum. Again, you have to follow all the rules. Like, they only allow you to have a couple of elbows. If you got more than a couple of elbows, then you have to reduce the capacity by a certain percentage. So typically for every 90-degree elbow more and beyond that, you have to reduce the capacity in the tables by another 10%. And again, you're reducing the capacity of the table, not the capacity of the furnace, is what you have to do. And there are also the fan-assisted appliances, which you have to deal with the min and max on those. And those are a little bit more forgiving, but as you can tell, a 4-inch furnace that has a single wall connector, you can see how the minimum is up to 75,000 and you have 102,000 for the fan max. The problem with that is that they figure they're going to get enough heat loss through that single wall pipe that they're very concerned about us using that. So I think that's one of those things that you have to be very cautious of with these fan assisted appliances on here. So if that would be a better application, oftentimes would definitely be switching it to B-vent as much as you possibly can. And this is no different than if you're going to do any type of an application with a B-vent. So if I were to go and say, well, what if we didn't use single wall? What if we used a type B and we had a 5-foot lateral? That would completely change the game if it were a 4-inch natural max. The natural appliance would give us the ability of 70,000 for natural from 69, which isn't a big difference there. But for the fan min and max, that's really significant. And that's where they're going to deal with 104,000 on the high side, but the low side is really where we gained a whole ton. And that has a capacity of 30,000 BTUs on the low end. Now, if you're dealing with an appliance that would be a multi-stage appliance, that could be really relevant. So again, be very, very cautious for those applications. So again, these tables are very straightforward. If you're using those, should not be a big deal on there. All the same rules that are going to apply for chimneys and vent systems and liners is, the higher the vent system, the more capacity that vent system will indeed have. So that would be typical. So for example, it just really expands the range. So a 4-inch fan minimum with a B vent would be 29,000 and 121 on the high side, whereas up here it was 30,000 on the low end and 104 on the high end. If I go to a single wall at a 25 foot and a 5 foot lateral, you can tell that we are at 73,000 and 119. So we gained some on the high end, on the maximum, but we gained a tiny little bit on the low end. Again, that it may become restrictive for you to use a single wall pipe on these applications. And then of course the maximum for a natural draft appliance, it would increase to 84,000 if it is for the maximum for natural draft. And then of course if you compare that to what you had at a 15-foot high system, we were closer to 70,000 on there. So just very straightforward application on these things like that. A lot of the same rules still apply for these, but again, if you're going to do any chimney liner sizing, I would recommend using, whenever possible, try to use the manufacturers of that application's their system sizing chart. For multiple appliances, I think the same thing applies here. You're going to use the same rules. You figure out your common vent height, what are your connector rises, and then you can identify those vent connector sizes for those individual appliances and their recommendations for that. It's not super common that you would be doing that, but it is something that occasionally you'll have to look at. And then of course for the common liner in a chimney, again, the same rules. You're going to have whether it's single wall or B vent, they're going to have fan plus fan, they're going to have fan plus natural, or natural plus natural. So it depends on the appliances that you're dealing with in here. A couple of little points that I want to highlight on here is they talked about the single appliance capacity table includes a 20% deduction for the fan max and natural max because of that corrugated liner. Lateral allowances are allowed they're made for those two elbows. So if you have more than 2 turns, you need to reduce them by 10% for every 90 degree turn or equivalent. And so again, follow those same types of rules. You're still very limited to, if you're dealing with multiple appliances, they also include a 20% reduction for the corrugated liner. Every elbow we require an additional 10% deduction, and you're also limited on the manifolds to 1.5 feet of lateral for every inch of the common vent connector or vent diameter that you have on there. So be very careful with those things. Again, follow those rules. Very straightforward on here. So these two descriptions down below here, these 2 pictures, they kind of identify what would it look like for a typical single category 1 appliance coming out of a vent system. There's one elbow here, there's a second elbow right on the bottom here, and then the same thing applies on here for the multiple appliances where you have a manifold. They're talking about what is this rise, what is this rise for the 2 different connectors, and then you proceed. So that is a little bit on sizing for sizing a chimney liner. It's very simple, very basic. If you understanding just the basic rules of common vent sizing, and also